In this video, we are going to focus on how to add vectors analytically. Now, we know that a vector is any quantity that have both magnitude and direction. Now, what if we have your vector A and your vector B, and the value of vector A is actually 50 newtons at is, and the value of your vector B is 30 newtons at is. Now, how are we going to add these two vectors? But first, let's try to graph these vectors. So we know that your vector A is going to the east direction with a value of 50 newtons. So this is your vector A. And we know that our vector B is going also to the east direction with have a value of 30 newtons. So this should be our vector B. This should be our vector B. And has a value of 30 newtons. So because they are both directed in the same direction, we are just going to simply add these two vectors. Now we know that these vectors are actually going into your east direction. Now we're just going to simply add them. And we know that the value of A is actually positive. The value of vector B is also positive. So whenever your vector is going to the east direction, it should always have a positive value. Now, simply, your resultant vector is actually equals to A plus B. And the value of your A is 50 newtons. And the value of your B is also 30 newtons. So we're just going to simply add this one. So 50 plus 80 is actually 80 newtons. So this is actually the magnitude of our resultant force. So again, whenever you have two vectors that goes in the same direction, we are just going to simply add them. Now let's try to have another example. Now let's say your vector A and your vector B. And the value of your vector A is 25 kilometers at north. And the value of vector B is 10 kilometers at south. Now what is the magnitude of the resultant vector and the direction? Okay. Now we know that your vector A is going to the north direction, which has a value of 25 kilometers. And now we know that your vector B is going to the south direction, so it should be like here, and it has the value of 10 kilometers. Now let's try to find the sign of these two values. Now we know that whenever a vector is going to the north, it should have a positive value. But when your vector is going to the south direction, it should always have a negative sign. Now we should know that our resultant vector is actually equals to positive A plus negative B, or just simply A minus B. Now the value of our vector A is actually 25 kilometers, and the value of vector B is 10 kilometers. Now let's try to subtract these two. Now 25 minus 10, we should have the value of 15 kilometers at north. Now this is actually the value of our magnitude of the resultant force, which is 15 kilometers at north. We should know that it has a positive sign here because we know 25 is greater than 10. So whenever we have a resultant vector that has a positive value, it should always go to the north direction because we know that your vector A is a positive and goes to the positive or to the north direction. So the direction of our resultant force is actually in the north. Now let's try to have another example. Now let's say your vector A and your vector B. And the value of vector A is 35 meters at west. And the value of vector B is 25 meters at west also. Now first thing to do, of course, is to graph these two vectors. Now we know that your vector A is going to the west direction, which has a value of 35 meters. So this is our vector A. And your vector B is also going to the next or to the west direction, which has a value of 25 meters. Now we know that our vector A has a negative sign because it goes in the west direction. And the sign of your vector B is also negative because it goes in the west direction. Now again, whenever we have two vectors running in the same direction, we are just simply going to add them. So basically, your resultant vector is actually equals to negative a plus negative b, or just simply negative a plus b, because negative times a is actually your negative a, and negative times positive b is actually equals to negative b. So rewrite the given value. Negative value of a is 35 meters, and the value of your b vector is 25 meters. Now, negative 35 or 35 plus 25, we should get a value of 60 meters at west. Now, it should have a negative value because we know that we're going to add two negative vectors, which is your 25 and 35. And we should also know that direction should be in the west direction because these two vectors are actually directed into the west direction. So that is how you do it. Now, sometimes vectors do not run in the opposite direction nor in the same direction. Most often, they run perpendicular to each other. For example, let's say your vector A and your vector B, and the value of vector A is actually 25 kilometers at east, and the value of your vector B is actually 20 kilometers at north. Now, first thing to do, of course, we have to graph it first. Now, we know that your vector A is going to your east, and it has a value of 25 kilometers. And your vector B is going to the north direction, and it has a value of 20 kilometers. So, for our resultant vector, we are just going to simply make a straight line starting from the central axis going to the head of your last vector. So let's try to do it. So this should be your resultant vector, and we know that this is your A vector and this is your B vector. Now, if you are not yet knowledgeable on how to add vectors graphically, you may check on the description box below for another video tutorial of it. Now, for this example, we want to know the magnitude and the direction of your resultant first. Now, first thing to do is to try to look on this figure. Now, we know that this is actually an example of your right triangle. So whenever you have vectors like this, or whenever you have a right triangle, we are just simply going to use the Pythagorean Theorem, which has the formula of c squared is equal to a squared plus b squared. Now, we should know that your resultant vector is actually your side C or your hypotenuse, and your vector A is the side B or the adjacent, and your vector B is your A side or your opposite side. Now let's try to rewrite the given. We know c squared is what we are looking for, so c squared is actually equals to the value of A, which is 20 kilometers, and the value of B, which is actually 25 kilometers, so plus 25 squared. Now c squared is actually equals to 20 squared plus 25 squared, then we should get the value of 1025. Now, to cancel the squared here, we are just going to simply to use the radical sign or the square root. So let's try to have your square root right here and another square root right here. So simply cancel your squared. So the thing that is left is c is actually equals to the value of square root of 1025, which is actually equals to 32.01 meters. So it says that the value of your resultant vector has a magnitude of 30.01 meters. So that is how we get the resultant vector using the Pythagorean theorem. Now, next thing to do is to find the direction of the resultant force. Now, whenever we have a right triangle, the formula that we are going to use to find a certain angle is using your SOHCAHTOA. So basically, the formula of your SOHCAHTOA is actually equal to sine theta. It's actually equals to side A over side C, or just basically opposite over hypotenuse. And your cosine theta is actually equals to side B over side C, or adjacent over hypotenuse, and your tangent data is actually equals to A over B, or your opposite side over adjacent side. Now, whenever we want to get the angle of the resultant vectors, we are always going to use the tangent formula, which is this one. So let's try to rewrite the given values. So again, to get the angle of your resultant vector, we are just going to use the tangent data is equal to A over B. Now we know that data is what we are looking for. So tangent data is actually the value of A, which is actually 20 kilometers, and the value of B is actually equals to 25 kilometers. So tangent data 20 divided by 25, and you should have the value of 0.80. Now transpose your tangent data into this side. So data is actually equals to tangent -1 or raised to -1 times 0.80. So you should get the value of 38.66 degrees. So it says that your angle right here, because this is what we are looking for, has a value of 38.66 degrees. So whenever you have a value like this one, we should get the magnitude of your resultant vector with a value of 32.01 meters, and the angle of your resultant vector with respect to x-axis is 38.66 degrees. Now let's try to have another example. Now what if the value of your vector A and the value of your vector B, and the value of vector A is 10 newtons at west, and the value of your vector B is 115 newtons at south. Now what is the magnitude and the direction of our resultant vector? First, let's try to graph this one. Your vector A is going to this direction, which has a value of 10 newtons, and your vector B is going to this direction, which is way longer because it has a value of 115 newtons. So for our resultant vector, again, we're just going to have a straight line starting from your central axis going to your head of the last vector. So this should be our resultant vector. Now again, what we are looking for is the value or the magnitude of the resultant force as well as the angle of our resultant force, which is this one. Now we know that this is your C side or your hypotenuse side, this is your B side or your adjacent side, and this is our A side or our opposite side. Now again, this is an example of right triangle. So whenever we have a right triangle, so as to get the resultant vector, we are just going to use the Pythagorean Theorem, which is again C squared is actually equals to A squared plus B squared. Now we know that the value of C is what we are looking for, and the value of A is actually 115 squared, and the value of B is actually equals to 10 squared. Now, the value of 115 squared plus 10 squared must have 13,325. Now again, square root this one and square root this one. Then cancel your 2, so bring down C. C and the value of your square root of 13,325, and you should get the value of 115.43 newtons. Okay? And you should know that your resultant vector should always be longer than your A vector or your B vector. Now it tells that the value of your magnitude of resultant force has actually the value of 115.53 newtons. Now let's try to find the angle of our resultant vector. And we know the formula for getting the angle of resultant vector is actually tangent theta is equal to A over B. Now rewrite the values or the given values. Tangent theta is actually equal to the value of A, which is 115, and the value of B is 10. Now divide these two values, then tangent theta is actually equals to 11.15. Then transpose your tangent, so theta is actually equals to tangent -1 times your 11.15. So when you are going to calculate this one, you should have the value of 85 85.03 degrees. So it says that your angle here has a value of 85.03 degrees. Now question, which direction it goes to? We know that this is your west direction and this is your south direction. So basically the direction of this angle is actually south of west. Why? Because we are going to count degrees starting from your west going to south. Okay, so you have an angle of 85.03 degrees. Now what if I ask you what is the total angle of your resultant vector with respect to your x-axis? And this is actually our x-axis. So to do that, basically we're just going to find the angle starting from your 0 degrees, which starts here, going to your second quadrant and going to this direction from the end of your resultant vector. Now we know that the angle right here is 90 degrees, and also the angle right here is 90 degrees, and so the angle right here is 90 degrees. Now let's try to remove some values right here. Now for us to get the value of our total angle, we are just going to add this 90 degrees, and your angle right here. So 90 plus 90 degrees plus your angle right here, which is 85.03 degrees. And we should have the value of 265.03 degrees. So it says that your angle of resultant vector is starting from your x-axis or from your 0 degrees is actually 265.03 degrees. So that is how we do it. So let's try to have another example. What if the value of our vector A and your vector B, and vector A has the value of 30 miles at east, and the value of your vector B is 45 miles at south. Now first thing to do is graph your vector. Now we know that your vector A is going to the east direction and it has the value of 30 miles. And your vector B is going to the south direction and it has the value of 45 miles. Then draw our resultant vector, which should be like this one. Okay, this is our resultant vector. Now find the magnitude and the direction or the angle of our resultant vector. Now we know that again this is your C side or hypotenuse side, this is your B side or adjacent side, this is our A side or our opposite side. Now again use the Pythagorean theorem to get the magnitude or the value of magnitude of your resultant vector. So C squared is actually equals to A squared plus B squared. Now rewrite the values. C squared is actually equal to the value of A, which is 45 squared. The value of B is 30 squared. Now C squared is actually equals to the value of 45 squared plus 20 squared is 2,925. Now square root these values. Now we should get, now cancel this 2 or the squared, then the value should have C is actually equals to 54.08 miles. So it says that the value of the magnitude of the resultant force is actually equals to 54.8 miles. Now let's try to find the angle of our resultant force, which is this one. Again, our formula, tangent theta, is actually equal to A over B. Rewrite the given values. Tangent theta is equal to the value of A, which is 45, and the value of B, which is 30. So the value of 45 over 30 is actually equals to 1.5. Then transpose your tangent. So theta is actually equals to tangent negative 1 times 1.5. And you should get the value of 56.30 degrees. Now, we know that the value of your angle here has a value of 56.30 degrees. Now, at what direction? Now, again, we're going to count starting from your east going to south. So, your angle will be measured starting from east going to south. So the direction should have or should be at south of east. Now we want to know what is the total angle of our resultant vector starting from our 0 degrees. Let's try to do it. Now again, we want to know the value of your angle starting from 0 degrees going to this direction. Okay, we know that this quadrant 1 has 90 degrees, quadrant 2 has 90 degrees, and quadrant 3 has 90 degrees, and quadrant 4 has 90 degrees. Now basically, we're going to add this 4 degrees, which should have a total value of 360 degrees. Then just subtract your 56.30 degrees. Why? Because this angle here is 56.30, and we're just going to get the angle starting from here and going to here. So you should have the value of 416.3 degrees. So that is the total angle of our resultant vector starting from the x-axis or starting from the 0 degrees.